the master of elliptic functions. While Abel struggled in poverty, Jacobi flourished at Königsberg. Their simultaneous discovery created a friendly rivalry that pushed both to greatness and advanced mathematics by decades. "Man must always work," said Carl Gustav Jacobi. "God makes mathematics difficult because he wants us to persevere." Welcome to Men of Mathematics. Today, in Part 7, Tragic Geniuses, we meet Carl Gustav Jacobi, the functionalist. Born 1804, died 1851. Last time, we met Niels Henrik Abel, who proved the quintic unsolvable and pioneered elliptic functions, only to die at 26, 2 days before his professorship arrived. His paper, lost by Cauchy, his genius recognized too late. Carl Gustav Jacob Jacobi was born on December 10, 1804, in Potsdam, Prussia, to a wealthy banking family. Unlike Abel, Jacobi never faced poverty. His family could fund his education and research. He entered the University of Berlin at 16, already able to read the works of Euler and Lagrange in the original. Unlike Abel, fortune smiled on Jacobi. In 1827, Jacobi became professor at Königsberg, the university where Kant had taught. He would remain there for nearly 2 decades, attracting students from across Europe. His lectures were legendary. When Jacobi learned of Abel's work on elliptic functions, he wrote to Legendre, "Mr. Abel seems to have anticipated my work. I recommend him to you as an absolutely outstanding talent." The rivalry remained friendly. Both acknowledged the other's priority, were appropriate. They were pushing the same frontier simultaneously. The trigonometric functions sine and cosine arise from a simple integral. Elliptic functions arise from more complex integrals. These functions have 2 independent periods, unlike sine and cosine, which have only one. Elliptic functions appear throughout mathematics and physics: pendulum motion, the shape of rotating fluids, solutions to nonlinear differential equations, and modern string theory. They pervade mathematics and physics. Jacobi introduced theta functions, power series that provide the cleanest approach to elliptic functions. These 4 special functions encode deep arithmetic information. They connect number theory, modular forms, and the partition function. In multivariable calculus, the Jacobian matrix contains all first partial derivatives of a vector function. Its determinant measures how much the function stretches or compresses volumes locally. This appears in every change of variables for multiple integrals. In algebra, Jacobi discovered the fundamental identity for Lie brackets. This identity is essential to Lie algebras, quantum mechanics, and differential geometry. Jacobi transformed mechanics with his reformulation of Hamilton's equations. The Hamilton-Jacobi equation provides a powerful method for solving problems in classical mechanics. This approach inspired Schrödinger's wave mechanics in quantum theory. Jacobi's masterwork, Fundamenta Nova Theoriae Functionum Ellipticarum, published in 1829, systematized the theory of elliptic functions. It became the standard reference for generations. The work appeared the same year Abel died, a bittersweet coincidence. Jacobi made deep contributions to number theory. He proved the 4 squares theorem. Every positive integer is a sum of 4 perfect squares. For example, 42 equals 1 squared plus 4 squared plus 5 squared plus 0 squared. His theta function approach gave explicit formulas for the number of representations. The aim of mathematics is the honor of the human spirit. Jacobi was a gifted teacher. His seminar at Königsberg trained many of the next generation's mathematicians. In 1843, Jacobi fell ill, possibly from overwork. His patron, the King of Prussia, had died, and his financial situation deteriorated. He moved to Berlin and struggled with health and money until his death from smallpox in 1851. Even 46 years wasn't enough for all his ideas. As E.T. Bell wrote, Jacobi was one of the greatest algorithmists of all time. His fertility of invention was prodigious. Next time on Men of Mathematics, we meet William Rowan Hamilton, the Irish prodigy who knew 13 languages by 13 and invented quaternions in a flash of insight on a Dublin bridge. He spent 20 years searching for that insight, and the rest of his life trying to make it useful. Thank you for watching Men of Mathematics. Subscribe for new episodes every week. Next, William Rowan Hamilton,